Right, okay, let's look at the question first. What the question is saying. You are given the coordinate of a VOR. So where is the VOR on the ground? It's on 45 degrees north latitude, 10 degrees east longitude. Right? You're also given where your aircraft is. Where is the aircraft? 44 degrees north latitude and 10 degrees east longitude. Right? Now, when we talk about latitudes and longitudes, you have to particularly understand that it is all on the earth, on the globe, on the chart and stuffs. Right? This is where you can find the latitude, longitude, all those things. Right? Make sense? Yes. So, let's draw this. Now, you know the basic structure and stuff, so we have seen all this in general now. So I'll just draw lines basically here. So we have two different latitudes. Which one should I mark, 44 and which is 45?
The one 45, the lower one 42.
The north one is definitely 45 degrees and the south one is 44 degrees, right? No confusions here? Perfect. Now we also have longitudes, and what you find here is both your aircraft and the VOR have the same longitude. They are on the same meridian. Did you realize that while doing the question?
Yes.
Both of it is on the same. Did you try drawing this a diagram and marking those? Probably you should have started like that. So let's draw the meridian here. This is the longitude value of the meridian is 10 degrees east. Right now, it's again important to mark the VOR and aircraft properly. Okay, so this is the point where your 45 degree north is intersecting with 10 degrees east, and that is where the VOR is. Right, so the VOR is right here. Right, this is point A, where you have the VOR. Where the aircraft, where 44 degrees north lat coincides with 10 degrees east long, this is where you have the aircraft. Doesn't matter what the heading of the aircraft is, so I'm not placing the aircraft just by a dot here, but this is the aircraft, right? Perfect. So what you have to understand this here is this is actually on a chart. It could be on the globe or on the actual surface of the earth, right? But it is on one of those, right? So you have to find out the radial of the aircraft. That's all, right? Let me draw the radial here. Radial is that particular bearing or track that is coming out from the VOR. That is what is called as radial. Therefore, the aircraft is on this particular radial here. Does it make sense? This is the radial of the aircraft. The aircraft is right here, and therefore the aircraft is on this radial. You're asked to find out the value of this radial, right? So remember, what is the definition for radial? Radial is nothing but the magnetic track from the station. That is why it is called as a QDR, right? Let me put this in words. It is magnetic track from station. Look at this particular line that I have drawn here. Let's see what all it satisfies. It is from the station, which is correct. It is from the station, right? It is a track. Yes, it is a track because it's actual line drawn on the surface. It has to be track, right? But what about this one here? Is this a magnetic track? That is where the point is. This is drawn on the Earth's surface, on the globe, on the chart. Therefore, it is always with respect to true. Isn't it? Because it's true north. So it's everything. Whatever it is drawn here, the lat, long, everything. You can see the longitudes. It emerges from true north towards true south. Therefore, even we have studied this before. If you kind of follow through your local meridian up north, you will reach true north. You have to use a magnetic compass if you want to reach the magnetic north, not the meridians, right? Therefore, everything is right. It is a true track. It is a track. It is from the station, but it is not magnetic. The only thing which you have to do is you simply have to find out the magnetic track. So what is this at the moment? It is not magnetic, but it's simply true track from the station. And what is that?
180.
True track from station. What is the Q code? True track from the station. What? QDR is magnetic track from station.
Magnetic.
It's QTE. You should know the Q code, sir. Day, night. You should know that. So true track from the station is QTE. Yes, Apeksha, what is this true track of the aircraft from the NDB, from the VOR? What is the true track? You have to first find the true north. If from here, if I track along the local meridian, I will reach true north. So from the true north, I have to measure clockwise towards the track. So what is the track here? 180. You already know that when you track from a point towards south along a meridian, the track is 180. Towards north is 360. But this is 180 degrees true. Therefore, QTE or is 180 degrees true. You will definitely have this in the option. Do not go for this because it appears to be 180, but that is correct. But that is QTE, not the radial, because radial is not QTE, it is QDR. How will you find QDR if you have QTE? And this is another point which you have to very particularly understand. How will I find QDR, which is a magnetic track from station, if I have QTE, which is a true track from the station? What connects these two? This is true value, this is the magnetic value from the station. Variation, yes. Now for that you have variations given in the question. You have variation at the VOR is 10 degrees west. This is the variation at the VOR, which is 10 degrees west. And the variation of the aircraft, because the aircraft could be at a different location, right? The variation at the aircraft is 15 degrees west. Which variation will you take? Now this is critical, very important here. In case of an NDB based system, we will see the NDB situation very soon here. In case of an NDB system, where is the measurement done? It is at the aircraft, right? We know that NDB is a non-direction beacon because the information from the NDB does not have any direction component in that. It is up to the ADF. Using the loop theory, the ADF has to determine the QDM, which means all measurements are done at the aircraft. Therefore, the variation of the aircraft should be taken in case of an NDB system. In case of a VOR system, the radial, which radial you are on, is not determined at the aircraft. What the aircraft simply has is a receiver system and a display system like the CDI, HSI or RMI. The entire measurement is all and a setup is all done at the ground station, at the VOR ground station. Therefore, in case of a VOR based system, variation at the VOR, V for V, the variation of the VOR should be taken. In case of an NDB based system, the variation of the aircraft should be taken. Did you understand? That's because I cannot take the variation of the aircraft and apply it to something that was measured at the VOR. It doesn't match. Therefore, I have to take the variation of the VOR and apply to something that was already determined at the VOR to find out this QDR. So in the question they will give you both the variations. If it is a VOR based system, which variation should you take? Variation always at the VOR, V for V. If it is NDB based system, you have to take the variation of the aircraft because all the measurements happen at the aircraft site, not at the NDB. So I cannot take a value measured at the aircraft and apply the variation of the NDB. It doesn't match. That is the whole idea. So here I have to take the variation, but variation at where? At the VOR. What is the variation of the VOR?
10 degrees west.
10 degrees west. Now it is your piece of cake here. We have the true value is 180 degrees true. How will you find the magnetic value if the variation is 10 degrees west? So 10 degrees west means your magnetic north is actually west of true north. Therefore, it's going to be a higher value. So variation west, magnetic is west. So what is the QDR? Magnetic has to be best, which means it has to be 180 plus 10, which is 190 degrees. It becomes magnetic. So this is 190 degrees magnetic radial. So what is the radial of the aircraft? 190 degrees. That is the radial. Do you understand? So two things you understand here. First of all, whatever you have drawn here is a true value, and what is asked is a radial. Therefore, it is a magnetic value. You have to apply this conversion by applying the variation. The second thing, which variation will you take? You have to take the variation at the VOR. If only one variation is given in the question without specifically mentioning whether it's at the aircraft or VOR, you can take it as a VOR variation. But if it is separately mentioned like this, you have to go for the variation at the VOR. Now before you copy this, I want you to look at the same scenario but using an NDB. The exact same thing using an NDB. So let's see here. If it is an NDB, there is no concept of radial, but basically we are trying to find out the aircraft's QDR, which is the same thing as radial. You don't call it as a radial in case of an NDB. So in case of an NDB, what we do, if it is an NDB based system, this is the VOR. The QTE is still the same. 180 degrees, you have the NDB here, you have the aircraft here. Therefore, the NDB is also, in case of on a chart, it's aligned to true north. That's the symbol of true north. and then you measure it, it is 180 degree. But when you convert this to QDR, I won't call it as a radial here because in case of NDB generally we don't use the term radial, but it is the same thing. We call it as QDR. Which variation should I take here? It's an NDB based system, so I have to take the variation at the aircraft. In case of a VOR based system, when you think about V there, VOR is always the variation at the VOR, right? In case of NDB, it is the variation but at the aircraft side, which is 15 degrees west. So what is the answer here? QDR will be 180 plus 15, which is 195 degrees magnetic is the QDR of the aircraft in case of an NDB based system. Remember, you will have both these in the answer along with on the options along with 180. You'll have all these things to confuse you. So wherever you go wrong, you will still find the answer in the option, and you might go and click it and bang and wrong. Understood? So be very careful, look at the system and find out what variation to apply. Don't go for 180 because whatever 180 you're getting here is a true value. What they're asking is either the radial or the QDR, which are all magnetic values. Very important, huh? Yes, you can copy this. You can copy this for both VOR and NDB. So here the coordinates of VOR is given 40 north, 170 east, and variation at the VOR is 15 degrees west. Coordinates of the aircraft is 40 north, 175 degrees west, variation at the aircraft is 10 degrees west. You asked to find out the radial of the aircraft. Yes, we can drop the answers in the chart. See, it's on. What you can find here, unlike in the previous question, here both the aircraft and the VOR are on the same parallel of 40 degrees north latitude, right? So let's draw that. Now, one common mistake that I generally find when I give this question is in locating these meridians. Where is 170 degrees east and 170 degrees west? So you have to have that solid idea of placement, especially when you're looking from the anti-prime meridian side. So we will close now. You can come back.